Okay, good morning. Let me welcome you on our next lecture on research on safety and comfort of means of transport. As you already know, the main idea for this course is to give you sort of information about innovation research on safety and comfort. I don't want to give you the fundamental knowledge and fundamental information about the basic fundamentals of safety and comfort, taking into consideration, for example, the braking system, the crash test. It is what we have been talked about last week. So today and on our next lecture we'll work mostly on new approach in a research on safety and comfort of means of transport. And the main topic of today's meeting is the application of vibroacoustic methods for analysis of comfort and safety of means of transport. So I will try to show you what are the possibilities and what are the applicability of the vibroacoustics methods for the research on comfort and safety. Today we'll focus mostly on safety, but you will see how you can implement those vibroacoustics method and what are the possibilities to create new research, new test, new approach when we are talking about safety and comfort of the means of transportation. And we are not talking just about the road transportation, but we are also talking about the rail transportation, air transportation, and even about the maritime transportation. Okay, so let's start with short description about noise and vibrations. So first of all, we have to consider the noise and vibration when we are talking about the humans in terms of perception of those noise and vibrations, because the phenomena of noise and vibrations are not linear phenomena with simple linear perception. Perception is different according to the volume of dose of noise and vibration and according to the frequency of the noise and vibration, so of the dynamics. So as you can see here, everyone of us can easily understand that we've got objectively measurements to find the subjective feeling perception of the vibration and noise. And for example, when we are talking about the noise, it was developed that the decibel scale, which is non-linear scale, is more suitable to the perception of the noise. So you can see here the scale when we are talking about the air pressure. Yes, so if we are talking about noise, the source measurements of the noise should base on the measure of the air pressure, and you've got the value of the air pressure starting from 2.10 power minus 5. So you can imagine how low level of the air pressure is it, and the maximum level pressure is 20 pascal. And as you can see, the range between the minimum value and highest value is huge. That is how it was developed, the decibel scale, and recalculation of the air pressure into the decibel scale. Yes, so we are changing the scale, and then if we look the the decibel scale and non-linear scale, you can see that we will change the range from the air pressure to the noise level, starting from 0 decibel into the, for example, 120 decibel, which is correspond to the 20 pascal. So you can see that we did decrease the range of the scale from huge range into the range about 120 units. Yes, of course we can go upper with the sound level, but the differences in the scale is, as you can see, clearly visible. So how we should recognize the volume of sound level when we are talking about the perception? Yes. So the minimum value about 10, maybe 15, maybe 20 decibels should be considered as pretty noisy, pretty science place when you can almost hear the wind. Yes, it is noisy. It is not noisy, peaceful noise environment. Yes, if we are talking about the range between 20 and 40, about 35 decibels, you should understand this level of the sound as the noise generated by the wind boat. Yes, if we are talking about the level about 50 decibels, you should consider it as the perception of operating of the uh, home devices as dishwasher here. If we are considering the 70 decibel scale, we should consider the perception of the noise of the car vehicle. Yes. If we are talking about the 80 decibels, it is correspond to the noise generated by the heavy vehicles. And if we are talking about the scales above the 100 decibels, we should consider this as the scale of the airplane. So you can imagine, and probably all of us can hear the wind, can hear the wash machine, the airplane. So the scale of the sound pressure, it is between those values. It is how we feel the noise, how we perceive the noise. And I'm not talking about the subjective understanding of noise, because for someone noise will be the loud heavy metal music, and for someone it won't be a noise, it will be the best sound ever. So I'm not talking about this, I'm talking about the perception. Okay. And the same is about the vibration. We didn't not develop the universal scale for the vibration, but we did develop a universal measure of the vibration as Rothmel square RMS value for vibration. And you have to also consider the perception of the vibration is also subjective. Okay, so what are the most fundamental knowledge when we are talking about the noise and vibration in vehicles? Because uh, if we want to apply the vibroacoustics method into research on safety, first we have to know what are the fundamentals of the noise and vibration in vehicles. So impact of the vibration on safety and comfort of driving vehicles is quite obvious. That is why there are so many technical elements and systems which influence on vibration absorbing, including, for example, suspension system and shock absorbers. Changes of their exploitation parameters of those sub-assemblies or assemblies of the suspension can worsen functional efficiency of the absorbing of the vibration. We want to absorb vibration, not to expose the vibration into the passenger and the driver. The vehicle vibration is an unwanted effect, and it should be always considered as unwanted effect, because we don't want to feel vibration, we don't want to hear the noises. It is effect of the constant processes when we are talking about mechanical system, and it makes many difficulties, increasing, for example, the fuel consumption, which is not always considered. But if we will reduce the efficiency of the energy of transformation from the mechanical system into vehicles, the fuel consumption, which is the energy input into the system, will be also increased. So if we will reduce the unwanted effect as vibration, and at the same time we will increase the efficiency of the mechanical system, we can also expect the decrease of the fuel consumption. But also what is important when we are talking about the unwanted effects of the noise and vibration, that it's all very often it is source of damages of elements. So if elements are too much exposed, especially for the vibrations, or noises, but mostly on the vibrations, the probability of damage of those elements is increasing. For the driving safety and comfort, it is very important that we what kind and values of vibration are transferred into the road to the car body, because as you already know, the perception of the vibration and noise are not linear. So we not only the volume of the vibration and noise is important, but also the dynamics of those phenomena, taking into consideration as frequency of the vibrations and frequency on the noise. And it is due to also the resonance value of our organs, which is more sensitive on different frequencies of the vibrations, for example. The technical conditions, for example, of shock absorber in vehicle suspension is very important, because it is the element who is responsible for absorbing the vibrations. And for example, the shock absorbers determines the comfort and safety of driver. So the first approach of using the vibroacoustics methods is to diagnose and check the condition of the shock absorbers, because these elements are extremely important for the safety and comfort. So it is the first goal and first idea how to use the vibroacoustics method on research on safety and comfort. The results of use shock absorber and the bad conditions shock absorbers also increase of the braking distance, and there are a lot of research which shows how important is the good condition of shock absorber to decrease the braking distance. So not just the braking system, but also shock absorbers, because shock absorbers is responsible for ensuring the constant contact between the wheel and the road, and only if the constant contact is secure by the shock absorber, the braking system can be efficient. Okay, so dynamics and as the results, vibrations of the vehicles are compromised between safety and comfort. It is also always the the most difficult place when during the research on vibrations in vehicles, for example, to find out the compromise between the safety and comfort. Why? Because if we are talking about the safety, the most important condition is to secure the constant contact between the road and the wheel, because it will secure first of all the braking process, and second or the steering process and control process. Only if the wheel are on the road you are able to control the movement of the vehicles. So it is the condition if we will consider the how the shock absorbers should be designed for the safety. It should secure the 100% contact between wheel and the road. But from the other point of view, we are talking about the comfort. We are not, and one of the important issue when we are talking about the comfort of the road vehicles is the vibrations comfort. That is how the seats are so important. So when I'm considering the comfort of the driver or the passenger or occupants in the vehicles, the best situation for me if there will be no vibrations transfer from road roughness into the driver's seat. Yes, and how to do it? What is the best way to do to isolate the vibrations to the passengers? The best solution is if the wheel and road without with have no contact. So if my car will not drive but fly, and my wheels will not have contact with the road, I will not have to think about the isolation of vibration caused from the road roughness, because there will be no contact. So as you already see, the conditions are totally different. Yes, when I'm talking on safety, I'm looking for the constant contact of wheel and the road roughness. When I'm talking about comfort, the best idea is if I will isolate the source of vibration, which is contact between wheels and road. That is how we are looking for the compromise between the safety and comfort. Of course, the safety is also always the primary requirement, but the comfort is also a very important factor. So everything is about finding the compromise between those two most important issues. That is how the research, the vibroacoustics research, can be applied very easily in research on vibration, on research on safety and comfort. Okay, what are others information important when we are talking about phenomena of noise and vibration in vehicles? So you already know what are the conditions and the differences between the conditions of safety and comfort when I'm talking about the contact of wheel and road. What is also important that we should consider the frequency range of the vibration and noise generate in a vehicle. And in a lot of studies, if you look on the books and the papers, the range are limited from 20 to 100 hertz, due to fact about most important frequency which can affect on the human body. But it's not right. We should go a little bit more, especially when we'll consider the resonance phenomena, which are important when we are talking about the car vehicle. So when we are talking about a car vehicle, we've got two kinds of masses which can be analyzed in a vehicle. One is unsprung masses. Here, the unsprung masses is everything uh, before the suspension system and absorption of vibration. So it will be the wheels, it will be the tires, it will be elements of the suspension, but not the shock absorbers also. And then sprung masses is everything above. So it's all car body and more of the elements of the cars is sprung masses. Why it is important? Because if we'll divide our vehicles due to those two factors, unsprung masses and sprung masses, we can also consider the two different resonance phenomena, which is sprung masses resonance and unsprung masses resonance. And why we are dividing this resonance into those two factors? Because when I'm talking about the comfort, I should consider the sprung mass resonance. When I'm talking about the safety, I should talk about unsprung mass resonance. That is how it is good idea to analyze the two types of different resonances which can occur in the vibration systems, vibroactive system, considering as the vehicle. I would like to also show you a short movie about noise generated by cars, so you will see what we are talking about and what we are dealing when we are talking about the noise comfort of the vehicles. So it is noise between different road roughness. I hope that you can hear the sound and noise. You can hear the differences when the wheel is tracking different type of road roughness. So it is the first factor. How we can reduce the noise in the vehicles? We can reduce the noise outside of the vehicles by building the roads with different surfaces. So it is the first idea. The second are vibrations. So if you just could confirm that you can hear the sound in the presentation, it would be also very useful. So let's watch about the vibrations in the vehicles. So impact over isolated obstacles, traversal bars. You can hear also, you can see the vibration when you will observe the wheel. and the steering wheel, but you could also hear the correlations and the corresponds between the noise and vibrations. And the second example, impact over isolated obstacles, but we are talking about manholes covers. You will hear and see what we are talking about. You can easily see the vibrations on the wheels and on the steering wheels also. Okay, so these are the phenomena which are the fundamentals when we starting to conduct the research on applying the vibroacoustics method to have an investigation on the safety and comfort of the vehicles, of the means of transport. So what is another important set of knowledge you should represent when we will try to design the research, plan the research on safety and comfort using the vibrations? So it is the mathematical models when you can calculate the resonance phenomena, and you can analyze the conditions of safety and comfort. So it is the example of a quarter simplified model, as you can see here. So it is just 1/4 of the vehicle. So we can consider this model as the wheel and the tire and the sprung and unsprung masses. So it is the quarter model. So we've got the frequency spectrum over here, and as you can see, the low frequency are proper vibration of sprung masses, resonance reflections. The average value for the passenger cars is about 1-2 Hz, and it is sprung masses resonance. As you can see, these are low frequency of resonance, but you can easily see the maximum extremum value of the vibration, which can result as the discomfort in the vehicles. And if we will go a little bit on the right side and increase the value of the frequency up to 10 to 20 Hz, we will talk about the unsprung masses resonance. The scale between the unsprung masses and sprung masses, as you can see, is like this, because the unsprung masses is about 1/10 or even or even less than sprung masses, and you will see the resonance in the range of 10 of 20 Hz, and this range is important when we are talking about the safety of the vehicle. So if you will design the research methodology for the checking the safety of the vehicles, we should analyze this scope of the vibrations. If you will use the vibrations method to analyze the comfort, you should analyze this range of the vehicles. It is the model, as you can see, a quarter simplified model, and here you can find the real spectrum of the vibrations of the vehicle. So we've got the vibration registers on the register on the vehicles, and then by using fast Fourier transformation, we transform the waveforms of the vibrations into the spectrum of the vibrations. Here are the frequencies, and you can see that we can see the one maximum extreme value as the sprung masses resonance, yes, and it is correspond to the value of 1-2-3 Hz. And the second and third, it is the unsprung masses resonance. As you can see, we can find around 10 Hz and around 18 Hz the resonance value, which should be more investigated because it is something not usual, so we should think about this. But in the real signal, you will see also other components which can be very useful when we are talking about the diagnostics and self-conditioning methodology for the checking conditions of the safety or comfort of the vehicle. So don't forget about other components of the frequency also. Okay, when you are talking about the vibrations and noise, but mostly vibration, it is not just about the contact of wheel with the road surface, which was presented in the movies which I show you, but also about the whole movement of the vehicles. And if we will consider the whole movement of the vehicles, you can consider different types of the movement. First is longitudinal fluctuations, when the distance between next, we can say, obstacles, yes, is more than half of the length, when the distance between the axes in the cars is at least twice bigger than the distance between the obstacles. Then we are talking about the longitudinal fluctuation, when the conditions are even uh, smaller. So we've got the distance between axles, yes, L value uh, in a distance about distance between the obstacles, and half of the obstacles will have different situation, but it will also the longitudinal fluctuation. Another types are bounce, yes, bouncing, when our car is bouncing. So there we've got three different conditions: when the distance between axes is exactly the same as distance between the obstacles, next waves on the roughness, yes, we've got first types of the bouncing. Second types of the bouncing is the distance between axles is exactly double as the distance between the waves here. And another is when the distance between the axles is much less than distance between the next waves, we can say the next obstacles. And these are through three different types of bounce. So it also should be considered as the vibrations, because the movement of whole vehicles is also important factor when we are talking about the vibrations. So this is what I rather mention about the different types of the longitudinal fluctuations and bounce. And what is also important, we should consider also the impact of longitudinal fluctuation of the front and rear passenger. So it's different, it's not exactly the same, especially if the distance between the front row and second row and the next rows is bigger, that the perception of the vibrations at the same time will be different from the front passenger and the rear passenger, for example. So you have to consider important things as actual point of longitudinal fluctuation. So if it is the actual point right now, and you are exactly in the same point with the position of your seat, you will probably feel no displacements and no vibrations. But at the same time, on the rear row, as you can see, it will be significant displacement and significant perception of the vibrations. We are talking about the same time unit, about different perception between front passenger and rear passenger. So it should be also taken into consideration when we are talking about the research on safety, but mostly on comfort of the vibration in the vehicles. So another thing which is important as foundation and fundamentals of vibroacoustics method applied for the research on safety and comfort is considering the whole system as vibration transfer system from road roughness into the driver. So if we will consider if we represent this approach to understanding the comfort and the safety, but mostly the comfort, we can consider the vehicles as set of three types of filters. So first we've got excitation. So it is the contact between the surface of road and the wheel. So it is the place when we are generating the vibrations. First filter is filter in addition to proper frequency tire filters vibrations at proper frequency and strangleth their own. So it is the first level. If we will design proper tires, we can expect also the first level of absorbing of the vibrations. The second filter is, in addition to the proper frequencies vehicle filter vibration at proper frequencies at its strength there. So we are talking about the suspension system, about all technical elements which helps to isolate or absorb the vibration, but also the car body and seats. And the third filter, because we should understand that we are not talking just about the vehicles, we are talking about the anthropological model when we've got the human and technical system cooperating together. So the third system is passengers, yes, and the human, because passengers feel discomfort when frequency and size of vibration is up to them, lies in the feelings. So it's about the perception. So we should also consider the third filter as the human perception on vibrations, and all those factors are the most important factors when we are talking about the comfort or discomfort of the driving. So not just this, not just vehicle and suspension system, not just tires, but also the human. And it is probably the most difficult thing. So here you can see also the model which shows the influence of vibration on human body. It is model which shows the simplified mechanical system representing the human body standing. Yes, this is this right of the model, or as sitting. This is this right of the model in on a vertical vibration platform. So we've got the vertical vibration platform over here or over here for the sitting person and for the standing person. And here on the model you can see the resonance frequencies for different human body organs. For example, when we are talking about the head, the most dangerous frequencies for the head is frequencies about 25 Hertz. If we are talking about the ear ball, for example, the most dangerous for the ear ball due to resonance are frequencies between 30 and 80 Hertz. If you are talking, for example, about the chest, we are talking about the dangerous frequency about 60 Hertz, and it is probably the most easy to understand how, because if you will check your pulse, it is probably your pulse. So also this is important. And you can find different other important resonance frequency which are dangerous when the exposure for this resonance is too long. So we have to minimize the time when these frequencies will occur in the system, or we can reduce this frequency at all. If you will check up the value of those frequencies, you will find the frequencies almost everyone more than 3 Hertz. That is how the sprung masses resonance in the car vehicles shouldn't be not more than 2 Hertz, because everything between the more than 2 Hertz can be dangerous for us. Okay, so it is what we should remember. So this is the representation of the resonance frequencies of different organisms in the human body, which means that during the research you should find out exactly if the passenger is exposed for this value of frequencies of responses, or if you are designing the mean of transport, you should also try to use the devices which helps you to reduce the vibrations and time of exposure for this frequency. As you already see, the amount of frequencies is quite large, so it also shows how difficult it is to find and to design the means of transport, the mechanical system, which will be comfortable and safety in a range of all frequencies. And what is also important, because first of all we should consider, of course, those values during design or research process as the values correspond to the comfort, but also, especially for eyes, yes, for hands, we should consider those frequencies as the dangerous frequencies to the safety, because if you will use contact vision or you will use the hand control during the driving vehicles, you are first most important factor when we are talking about safety of the driving. So in few situations you should also consider those research as the research on safety, and I would like you to remember also this very important part. Okay, exactly the same situation as it was in the perception of the noise. It is in the perception of vibration, but you have to always remember that the perception of the vibration is also different when we are talking about the sitting posture or the standing posture. When we are talking about the sitting posture, the contact is our lower spin, we can say, lower part spin, and we are talking about the general vibration. And perception of general vibration for the sitting person is different than point vibration. So the point vibration is the vibration which are transferred into the human body by the feet or by the hand. So we've got the platform of our car body, yes, the floor of our car body, and the steering wheels of our car. So these are also the source of initial path of the vibration to the human body, and the perception for the sitting and general vibration and standing person acting on hands, on feet are differences. And what is important when we are talking about the vibrations perception, that the direction of the vibration is also important. So if we are talking about the longitudinal vibration or the vertical or horizontal vibration, everything is important when we are talking about the perception. So here you can find some scales for the perception of the vibration when we are talking about the range of frequency. So for the low frequency, less than 1/2 of the hertz is inner ear oscillate, and we can feel it as oscillation, motion sickness. So if you ever for example swim in a boat, maybe some of you have the oscillation and motion sickness, or some of us has the motion sickness in the car vehicles, because if we are talking about the bounce, we would talk about this frequency of the vibrations. That is how it is not comfortable due to this factor. When we are talking about the frequencies of the vibration starting from 1 hertz into the 60 hertz, we are in the range of the resonance frequency of hands, legs, back, heart, stomach, and we can feel those kind of vibrations as strokes or shocks. So it is how you should perceive this vibration. If we are talking about the vibration uh, on frequencies around 60, 70 to 120 hertz, it is very sensitive for the skin, and you will feel it as the prick. And if we are talking about the high frequency, more than 500 hertz, it is most vibrations perceived as the ear, so we can feel vibrations more as the sound and noise. So these are the scales and perception of the vibration which you should recognize. So as you could see, it is also about the frequency, not just about the volume of the vibration. Okay, so I think that as the introduction to the vibroacoustics methodology and application of vibroacoustics method into research on safety and comfort, and the most important fundamentals information about this, it would be uh, enough for today. And on our next lecture, we'll talk about the examples of applying of vibroacoustics method in the research of safety and comfort. So thank you very much.